Okay, class, let's do an application type problem where we're going to look at the graph of the function. So let me set it up for you. And this goes back to another problem, but just listen. It says the electric power, P, capital P in watts, delivered by a certain fuel cell as a function of the resistance, which is measured in ohms, in the circuit is given by P equals 100 times R divided by the quantity 0.50 plus R, quantity squared. Plot P as a function of R. Okay, now, this is where we have to make sure that we understand the problem, and we want to use values that are meaningful. This is an application type problem. So in this case, values of resistance in the negative have no meaning. So we're not going to use any negative values for R because they're meaningless in the physical world. Okay? So the smallest we're going to do is 0. And so if there's 0 resistance based on this problem, this becomes 0, so again the whole thing is 0, so we get 0. And so what I did was I plotted these points on the graph. And so if you notice something here, it starts at 0 and then it jumps up to this. So you go 1/4, you increase the resistance by 1/4 ohms, and the power goes up to this. And then if you go to 1/2 ohm, jumps up a little farther, 50, and then if you go to 1 ohm of resistance, it comes back down, and then from there, as the resistance goes up, it's decreasing slowly. And so if you look at the points here, it looks like it's doing something like this. So it's jumping up, going up very fast, and then it comes to a maximum value, it looks like, and then it starts slowly decreasing towards 0. So you can see that as resistance in a circuit increases, well, the power increases too drastically, but only to a certain level. And then the resistance starts to work against the power and it starts to decrease. Okay, so this is very interesting here. I found that interesting that resistance would lead to more power. Food for thought. Have a great day.